Imagine a giant metallic structure slowly circling the Earth, an outpost not of any superpower, but of India, a space laboratory where Indian astronauts conduct experiments in microgravity, monitor cosmic radiation, and test technologies for future Mars missions. That's the dream behind India's 2035 space station plan, a bold, high-stakes mission to place the Bharatiya Antariksh Station in orbit by the middle of the next decade. But the big question is, can ISRO really pull it off? Can India build and maintain its own space station in just 10 years? Let's break it down. The Bharatiya Antariksh Station, or BAS, is planned as a modular space station that will orbit roughly 400 kilometers above Earth. It's not going to be as massive as the International Space Station, but it will serve as a self-sustaining orbital lab, hosting 3 to 4 astronauts for months at a time. The idea is to use this station for long-duration human missions, scientific research, and as a testing ground for deep space technologies. To put it simply, this will be India's permanent home in space. Now, this idea didn't appear overnight. It's the natural next step after Gaganyaan, India's first human spaceflight mission. Once India successfully sends astronauts into orbit and brings them safely back, the next challenge is to give them a place to stay, a station that can support human life, handle docking of supply modules, and operate continuously for years. But building a space station is far more than sending a rocket up. It's about mastering sustainability in space. And here's where things get interesting. Before we dive deeper into ISRO's challenges, let's take a quick detour and understand something important: the concept of a shutdown or lockdown, and why it matters in long, complex projects like this. A shutdown is essentially a forced halt of operations, a situation where work stops due to lack of funding, political disagreements, technical setbacks, or external crises. Think of it like a system pause button, where all non-essential activity freezes. You may remember how NASA has faced government shutdowns in the past. When such shutdowns happen, engineers can't work, testing stops, and mission schedules slide. Even a few weeks of downtime can create months of ripple effects, because space missions are built on coordination, timing, and momentum. Now, while India hasn't faced a full government shutdown like the US, it has seen moments of institutional slowdown, periods where budgets froze, imports stalled, or major technical missions were delayed. The COVID lockdown was one such example, when most of ISRO's scheduled launches were postponed and mission timelines slipped by years. Those months of inactivity cost valuable progress, showing how even a small pause in the chain can have long-term impact. So when we talk about ISRO's 2035 goal, we must remember, consistency is everything. Any major shutdown in funding, focus, or resources could derail this delicate timeline. Now let's unpack the big challenges ahead for ISRO in making the Bharatiya Antariksh Station a reality. The first and biggest hurdle: funding and continuity. A space station isn't a one-time expense. It's a multi-phase project lasting decades. You need money not just to build it, but to launch modules, maintain them, and send regular supply missions. ISRO operates on a fraction of NASA's budget, and balancing this with other priorities like lunar exploration, Mars and Earth observation is no small task. Second, launch capability. To lift heavy modules into orbit, India will rely on its current workhorse, the LVM-3 rocket. But even that has payload limits. For larger, heavier components, ISRO will need to develop the next-generation launcher, stronger, reusable, and more efficient. If that rocket isn't ready on time, the space station timeline could stretch beyond 2035. Third, docking and assembly. A space station isn't launched in one go. It's built piece by piece, like cosmic Lego. Each module has to reach orbit, travel thousands of kilometers per hour, and then meet and lock precisely with another module already circling Earth. That's called orbital rendezvous and docking, a maneuver that requires microsecond accuracy. ISRO has been testing this through smaller-scale experiments, but achieving it safely for humans will be one of the biggest technical hurdles. Fourth, life support and habitability. Once astronauts are up there, the station must sustain them for months. That means stable oxygen systems, carbon dioxide removal, water recycling, waste management, temperature control, and radiation shielding. These systems need to be fully autonomous and fail-safe. ISRO has experience with satellites and robotic missions, but keeping humans alive in orbit for months at a time is a whole new level of challenge. Fifth, resupply and logistics. Food, water, experiments, spare parts, everything must be sent up regularly. India will need to develop cargo spacecraft capable of docking automatically with the station. Any delay in launches or mechanical failures could endanger the crew. Sixth, in-orbit maintenance. A space station endures constant radiation, solar storms, and micrometeoroid hits. Over time, panels degrade, seals wear out, and systems fail. Astronauts or robotic arms must be trained and equipped to repair the station in microgravity. ISRO has already begun work on robotic arms and autonomous servicing modules, but scaling that up will be critical. Seventh, international cooperation and standards. Most space agencies rely on shared hardware designs and docking mechanisms for safety and interoperability. India will need to either develop its own standards or align with existing ones, ensuring that its station can work with global partners in the future. Eighth, upgradability and obsolescence. A 10-year plan in tech terms is a lifetime. Hardware designed today may be outdated by 2035. ISRO must design with modularity, making sure each component can be replaced or upgraded over time without needing a full rebuild. And ninth, risk management and public confidence. Space exploration is as much about trust as it is about technology. A single high-profile failure, like a failed docking, a supply mission gone wrong, or a budget cut, can set the project back years and shake public and political faith. So, can ISRO really pull it off? The honest answer is yes, but only with relentless continuity and precision. If ISRO maintains a stable funding stream, keeps its teams focused, upgrades its rockets in time, and avoids institutional shutdowns, India absolutely can place its own space station in orbit by 2035. In fact, there's a hidden advantage: India's ability to innovate frugally. ISRO has repeatedly achieved world-class missions at a fraction of global costs. Whether it was Chandrayaan, Mangalyaan, or the Chandrayaan-3 lunar landing, that same efficiency could make BAS one of the most cost-effective space stations ever built. There's also a new ally, India's growing private space sector. Startups are now building launch vehicles, engines, and satellite systems. If ISRO opens the door to private collaboration, it can accelerate timelines dramatically. And then there's momentum. Once Gaganyaan succeeds, India will already have trained astronauts, life support systems, and ground infrastructure ready. The first step will likely be a short-stay orbital module, perhaps for a week or two. Then, gradually, more modules will be added, evolving into a full-fledged station by 2035. However, the key danger remains a potential shutdown, not necessarily political, but financial or technical. A funding freeze, an economic slowdown, or a series of mission failures could cause ISRO to pause and reallocate resources. Every pause means losing time, talent, and global advantage. That's why the next decade will be the most decisive in India's space history. The country stands at the threshold of joining a very small elite club of nations with independent human space infrastructure. The stakes are high, but so is the potential reward. Imagine it's 2035. The Bharatiya Antariksh Station glides over the Himalayas, reflecting sunlight as it crosses the night sky. Inside, Indian astronauts float weightlessly, conducting biological experiments, testing AI-controlled robots, and beaming live classes to students back on Earth. Each orbit becomes a statement, not of power, but of progress. It's not just about exploring space, it's about mastering continuity, innovation, and resilience in the face of uncertainty. So, can ISRO really pull it off? The science says yes. The engineering says maybe. But the answer, as always, lies in whether we can keep the engines running without a shutdown, without a pause, and without losing sight of the stars. This is beyond binary. Stay curious, stay informed, and remember, the future isn't out there. It's being built, one orbit at a time.